Hello friends, today we'll discuss about the challenges that motivated for the emergence of the deep learning. So mainly there are so many challenges, but mainly we can broadly classify as the feature engineering challenge, the high dimensional complex data challenge, and representative learning gap challenge, and the scalability issue, and limitations in sequential and structural data, and generalization and transfer learning, and real world application problems. So there are so many problems, and the first thing we will discuss, that is feature engineering. So earlier ML models on heavily relied on handcrafted features. So the challenge is the designing features required deep domain expertise, time consuming, and didn't get well across the tasks. The real solution is, here we are using the neural networks. Neural networks automatically learn hierarchical features directly from raw data like images, voice, etc. And the next challenge is high dimensional and complex data. The traditional models struggled with unstructured data like images, speech, etc. The challenge is the curse of dimensionality and poor scalability with complex data sets. The real solution is, here we are going to use the deep architectures when you compare with the traditional architectures. So that is the deep architectures like CNNs, RNNs, transformers exploit spatial, temporal, local correlations, handling millions of dimensions effectively. The CNNs means, that is convolutional neural networks, exploit spatial local correlations such as neighboring pixels in images or local patterns. The RNNs, that is recurrent neural networks, exploit temporal correlations, that is in time series. And the transformers, so these are very special, exploit global contextual correlations using attention mechanisms. So they will be having attention mechanisms in extra to capture relationship between elements regardless of distance. Okay. Next, the challenge is the representation learning gap. The traditional methods used to have this learning gap because the shallow models have limited capacity to learn abstract representations. The challenge is difficult to capture hierarchical concepts, example from pixels, edges, shapes, objects. The real solution is deep layers progressively capture higher level abstracts. The next challenge is, the important challenge is generalization and transfer learning. The ML models were task specific and lacked adaptability. The challenge is needed retaining from scratch for each new problem. The real solution is pre-trained model plus transfer learning plus time tuning that will give the better use across domains. Real world applications demand is another challenge. The AI applications like autonomous driving, speech assistance, medical imaging require high accuracy and robustness beyond ML. The challenge is safety, critical and large scale tasks were out of reach. The real solution is, so the DL outperformed traditional ML in vision and speech. The another challenge is scalability issue. The classical algorithm hit performance ceilings when data volume increased. The challenge is could not fully exploit big data era. We are living in a big data era, don't forget it. The deep learning solution is the performance improves with more data plus large models with scaling loss. Limitations in sequential and structured data is another problem. The traditional models poorly handle sequential dependencies, example speech, language, time series. The challenge is long-term dependencies and contextual meaning were lost. The DL solution is RNNs, transformers, etc. capture sequential and contextual dependencies effectively. So these are majorly the challenges which demanded for the emergence of the deep learning. The main thing is the DL is better version of the ML. So here we are having the deep layers, large models, okay, large structures, deep architectures. So that is why it is performing better when you compare with the ML. Okay, thank you for listening. Thank you very much.